This video is an introduction to three new trig functions known as the reciprocal trig functions. And these, as you can see from the title there, go by the titles sec, cosec and cot. They're based on the three familiar trig functions cos, sine and tan. And I want to have a quick look at the definitions and perhaps just a quick look at the graphs to see if we can see how they behave as well. So the definitions here. So we talk about, for example, sec theta. And this is defined just as being the reciprocal of, therefore 1 over cos theta. So sec theta is defined as 1 over cos theta. And similarly for the other two, cosec theta is the reciprocal of sine theta, so that's 1 over sine theta. And the last one is cot, and so we have cot theta, which is defined as the reciprocal of, and therefore 1 over tan theta. These words sec, cosec and cot are just abbreviations. Sec is short for secant, cosec is short for cosecant, and cot is short for cotangent. You'll very rarely see those, but you might come across them somewhere, so just didn't want you to be unfamiliar with them. But perfectly acceptable too, and almost always done, that we just refer to them as sec, cosec and cot. Notice that you need to be clear and sure about which one is which. I think in my head there's a bit of potential confusion between sec and cosec. Sec looks a bit more like sine because it starts with an S. Cosec looks a bit more like cos because it's got the word cos in it. I'm sorry about that. There's nothing I can do about that, I'm afraid. It's just the way it is, and so you just need to be alert to it and try and find a way, if you can, of remembering which one is which. So sec going with cos, cosec going with sine. You need to find a way of remembering those things. Cot, I think, is more straightforward to remember because it's got the T in it, so that doesn't seem so bad. The other thing I think to say at this stage is to note that although where we often use the notation for example, if I take, I don't know, cos theta and I want to square it, then I will often write that in the form, and you'll be familiar with this, as cos squared theta. You're putting the power above the cos word and in front of the theta, and the same would be true if it was sine or tan, so like that, sine squared or tan squared or whatever it might be of theta. Notice here that sec theta is not the same thing as cos to the power minus 1 theta. In fact, you should never really see cos to the minus 1 of theta, because theta tends to get used for an angle, and if I do cos to the minus 1, it's generally speaking not an angle that I would be putting in there, because cos to the minus 1 there means the inverse of cos. It doesn't mean the reciprocal of cos. And in fact, as you go further into your maths, you'll see less frequently people using cos to the minus 1 of the cos to the minus 1 of something, and more commonly using an alternative notation, which is arc cos. I don't know whether you've come across that one yet though. But please notice, certainly your cos to the minus 1, sine to the minus 1, tan to the minus 1 comes up on your calculator. That is not the same as sec or cosec or cot. If I want to write sec theta as a power instead, a power of cos theta instead of just as sec theta, then I would have to put my cos theta in a bracket, like I did with that first squared one up here, the left hand side of that one. I'd have to put my cos theta in a bracket and then put a power of -1 on the bracket. So we use this kind of squared notation, cos squared theta. We tend to use that only for positive integer powers of cos or sine or tan, and not for any other power, because of that potential for confusion there. So two possible areas for confusion, I think, here, just the names, mixing up sec and cosec, and making sure you know which one goes with cos and which one goes with sine. That's one potential area for confusion. And then this potential area for notation confusion as well, thinking about a power of -1 as a reciprocal kind of thing. Yeah, so just watch out for those two possible areas for confusion. That's it, essentially. Those are the definitions. I think while you're familiarizing yourself with those definitions, so perhaps it's useful to take a look at the graphs of sec theta, cosec theta, and cot theta. And I think the easiest way to do that is to think through how that works out in relation to the graphs of cos theta, sine theta, and tan theta. So I've got those pre-prepared up here. So this first one is a graph of y equals cos theta. And which function is it that goes with cos theta? Did you get it right? Yes, it's sec theta. So cos theta, what I'd like to do is superimpose or draw alongside my cos theta graph there, the graph of sec theta, because that's the one that it goes with. And so all I need to do really here is to think about the y value of each point on the graph and think, to get the sec theta graph, what would I get by dividing my cos theta y value, my cos theta value, dividing 1 by that cos theta value to work out what the sec theta value is. So for example, well, the easiest place to start is the peaks of each wave of my cos theta graph. So the peak is at 1, so all I'm doing there is to get my sec theta value, I'm just doing 1 divided by 1, so that's going to mean it's going to give me the same value. So in fact, the graphs are going to coincide at each peak. And in fact, they'll coincide at each trough as well, won't they? Where they're -1, I'm doing 1 divided by -1, so those are going to give me -1 as well. So I've got the same kind of effect going on at each trough as well. So as we move out, let's start with this first peak on the y-axis. As we move outwards from that, perhaps to the right, my cos theta value is decreasing. So I'm doing 1 divided by a smaller and smaller value all the time. And I'm getting closer and closer to dividing by 0, which of course we can't do, or it's going to give us, we don't really like to talk about it, but it's going to be, we'll think about it as giving us infinity, won't we? So in fact, what we're going to end up with here is an asymptote. I hope you're familiar with an asymptote, a place on the graph where the function shoots off towards infinity or possibly negative infinity. So as I go out from this first peak on the y-axis, my sec theta value is going to start at 1 on that point, and then it's going to increase all the time. It's going to get closer and closer to that dotted line, but never quite reach it as it goes off to infinity there. And then actually down here, it's going to do the same kind of thing. Starting at -1, I'm dividing by less and less each time, so I'm going to get more and more, bigger size answer, but more and more negative all the time. And so I'm going to be going closer and closer to negative infinity as I get. Sorry, that shouldn't have crossed over that dotted line. But there we are. And then by the symmetries, I can just fill in a symmetrical kind of shape. Fill in a symmetrical kind of shape alongside it. So that's going to shoot off towards positive infinity there, and similarly down here. And that pattern just gets repeated cyclically, just like your cos graph does. So each time the cos graph goes through 0, that's a new asymptote. And so we've got another copy of that N shape here. Got another copy of the U shape at the top coming in here. Okay, marginally better at these as I draw more and more of them. That kind of thing, and just repeats all the time. And actually, once we've done that, very straightforward to look at the cosec one. So here on my second graph, this is my y equals sine theta graph, and I'm going to do a similar job here, imposing on top of that one. So which goes with sine? Did you get that one right as well? Yes, that's cosec theta. So I'm going to superimpose my cosec theta on top of this sine theta graph. So here my peaks are at the pi over 2, and then 5 pi over 2 and all the rest of it. And my zeros are at 0 and pi and 2 pi and all of those things. So I've got exactly the same shape as my cos graph, cos and sec graph, but just shifted around a bit. And this time the y-axis will be an asymptote. Sorry, that didn't meet quite at the bottom there, it was supposed to. And the same kind of thing going on here, just repeating those shapes cyclically. Oh, sorry about that wobble. Just repeating those shapes cyclically like we did on the sec graph. So there's my cosec theta graph. Notice with those two, then it's just the black lines here, which are representing sec theta and cosec theta. Notice that there's a great big gaping gap between the bottom of each trough and the top of each peak here. So there are no values of sec theta or cosec theta between -1 and 1. That just doesn't happen. And the last one to look at here on the bottom here is the slightly different one. Is my tan graph, and obviously I'm going to be going alongside that. I'm going to be drawing my cot graph alongside it. So tan theta here, and in black I want to superimpose on top of that a cot theta graph. And just by thinking about things that's in the same sort of way, every time it goes through 0, the blue line, the tan theta line, that's going to be an asymptote, because I'm just doing trying to do 1 divided by 0 and can't do it. As I go through 1s and -1s, they're going to coincide, and as the tan theta graph shoots off to infinity, if I'm dividing one by positive something very close to infinity, I'm getting closer and closer to 0 all the time. So we're going to go through zeros at these, at these half pi points on the theta axis. Those are going to be 0 points. And so I get a shape which does essentially something like this. Sorry about the little wobble there. And then that just repeats. So actually it looks very like the tan graph, but sort of flipped, sort of reflected round. That just again repeats in a cyclical way, just like the tan theta cyclical graph. So there we are, 3 definitions of new trig functions: sec theta 1 over cos theta, cosec theta 1 over sine theta, cot theta 1 over tan theta, and just a very quick look at the graphs. You will notice these functions don't come up on your calculator anywhere, so if you ever have to calculate values, you will have to do them as the reciprocals of the cos, sine and tan functions.